Welcome back. So far we looked at batch processing. That's when you have all your data sitting quietly on a hard drive, like a calm lake, and you can take your time, analyzing it. What happens when the data never stops, basically? Think about global Twitter or X traffic, or every credit card transaction happening in the world right now. You can't store a stream; it's infinite. If you try to save everything to a hard drive to analyze it later, your hard drive fills up, within hours. You have to process the data in RAM as it flies past you, and then you have to let it go forever. Because our RAM is, it's not infinite, it's finite, and the stream is infinite, we face a harsh reality in data engineering. We cannot have perfect answers anymore. We have to accept approximate answers. To survive the stream, we rely on heavy mathematics, specifically hashing, to give us answers that are good enough while using a fraction of the memory. So let's say you want to filter a stream. Imagine a stream of billions of incoming emails, and you need to block, known spam addresses. You don't have the RAM to keep a massive list of 10 million spam addresses in memory. Instead, we use a brilliant data structure called a Bloom filter. A Bloom filter is just a simple array of bits, zeros and ones, where a known spam email like address will come in. We don't know the address itself. We run it through, say, three different mathematical hash functions. These functions point to three random slots in our array, and we turn those slots from a 0 to a 1. Now, when a new email arrives, we hash it three times. If it points to three ones, we block it. If we assume it's spam. But what if it points to even a single zero? Then we know with 100% certainty it is not on our spam list. It passes. Because of how hashes overlap, there's a tiny chance a legitimate email accidentally hashes to three ones that were turned on by other spam emails, and this is a false positive. But there are absolutely zero false negatives. It is a highly efficient way to filter millions of items using just kilobytes of RAM. Filtering, is one thing, but what if you want to count things in a stream? Suppose you want to know exactly how many times one appeared in the last billion bits of network traffic. Again, you can't store a billion bits in RAM. To solve this, we use DGIM algorithm. Instead of remembering every single 0 and 1, DGIM groups blocks of ones together into buckets. But here's the trick. The buckets grow exponentially into powers of 2. For the most recent data arriving right now, the buckets are tiny, holding one or two items, so we have perfect accuracy. But for older data moving out of our window, we merge them into larger and larger buckets, holding 4, then 8, then 16 items. We compress the history. When you ask the algorithm how many ones were there, it sums up the buckets. Because the final oldest bucket is just a massive block, we don't know exactly where the ones fall inside it, which means the DGIM algorithm guarantees a maximum error of 50% of that final bucket. So we trade perfect precision for the ability to actually survive an infinite stream without crashing our servers. Thank you for watching.